This is the mark scheme for the test on oxygen and carbon dioxide. The first question, oxygen exists as a diatomic molecule. What does this term diatomic mean? It's got 2 marks, this question. 1 mark for saying that it consists of 2 for the word di and atoms for the word atomic. So you need to get 2 and atoms in your answer to get the 2 marks. Name the biological process that requires oxygen as a reactant. The answer is respiration. Remember that glucose and oxygen gives carbon dioxide and water in respiration. Next question. Name the biological process that releases oxygen as a waste product. And the answer is photosynthesis. Remember that carbon dioxide and water gives glucose and oxygen, oxygen being a waste product. Next one, you just have to learn the next one, which is give the name of the catalyst that we use in the preparation of oxygen gas, and the catalyst is called manganese 4 oxide. Okay, you need to put the 4 in to get the mark. Okay, manganese 4 oxide is the answer to that. In the space below, draw a diagram of the apparatus you would require to prepare oxygen in the lab. Label the diagram. So what we've got here is we've got some sort of conical flask. It doesn't have to be conical, it could be a round bottom flask. You have the manganese 4 oxide in there, and then you have some device. We used a thistle funnel. This isn't a thistle funnel, but this would work. And you put the hydrogen peroxide in there, release the hydrogen peroxide onto the catalyst, manganese 4 oxide. It then breaks down to produce oxygen gas, which comes up through here. It goes through this beehive shelf here, which you could label, which is in a water trough, and that displaces water from a gas jar. So the things that you might have labelled here might be that structure there, which is called a beehive shelf, and this structure here, which is called a gas jar. So those are the things that you might label on that structure there. Moving on to the next question. Write a balanced symbol equation for the reaction involved in the preparation of oxygen in the laboratory. Give state symbols. So in this case we've got hydrogen peroxide, which is H2O2, and that breaks down into water and oxygen. We have to balance the equation. Okay, so we need 2 H2O2s, gives 2 H2O plus just 1 lot of oxygen, and the state symbols would be aqueous for the hydrogen peroxide dissolved in water, and water is liquid and the oxygen is a gas. Moving on to the next page. So very quickly, the next sheet we have magnesium, asking magnesium and oxygen, write balanced symbol equation state symbols. Magnesium is Mg, oxygen diatomic molecule, gives magnesium oxide, which is just MgO. The reason that it's MgO is because both magnesium and oxygen have a valency of 2, therefore it's just MgO. State symbols, balancing, we then have to put a 2 in front of that and a 2 in front of that to balance it all up. So we have 2 oxygens over here, 2 oxygens here, 2 magnesiums here, 2 magnesiums here. State symbols, that's a solid, that's a gas, that's a solid. Is the product of the reaction in question 7 acidic or basic? The answer is basic, because all metals, for example magnesium, are basic. Sulfur also burns an oxygen. Write a balanced symbol equation with state symbols for this reaction. Sulfur is just S, which is a solid. Oxygen, which is a diatomic molecule, which is a gas, goes to sulfur dioxide, which is a gas also. No balancing here because it balances anyway. Is the product of a reaction in question 9 acidic or basic? The answer is acidic because sulfur is a non-metal and all non-metal oxides are acidic. From the answers to question 8, and that should actually say 10, we can make up the following rule. Fill in the missing words. Non-metal oxides are acidic, metal oxides are basic. And then describe a laboratory test for oxygen, and the answer is simply 1 mark for saying it relights, a 2nd mark, a glowing splint. The next question, in 1901, a gentleman in Glasgow called A.G. Barr invented a magical orange-coloured fizzy drink called Iron Brew. The fizziness was due to a gas called carbon dioxide, which is dissolved into the drink to form a weak acid. Okay, it's acidic because carbons are non-metal and all non-metal oxides are acidic. And remember, this is one of the uses you've got to know for carbon dioxide, is it's used in the production of fizzy drinks. So here we have the next question is draw a diagram in the space below of the apparatus you would use to prepare carbon dioxide in the lab. So here we've got a flask of some sort, in this case it's a round bottom one, it could be a conical flask. Into that flask you have a thistle funnel, and out of that flask through a bung you have a delivery tube. You pour hydrochloric acid into the thistle funnel, which comes down into the flask, in which is the marble chips or calcium carbonate. Reaction occurs which produces the gas carbon dioxide, which is then delivered through the delivery tube to the gas jar. Remember, carbon dioxide denser than air, and therefore it displaces the air out of the gas jar. So that's the diagram for the laboratory preparation of carbon dioxide. Next we have writing the balanced symbol equation for that. Calcium carbonate or marble chips plus hydrochloric acid gives CaCl2. Now, the formula for CaCl2 is CaCl2 because calcium is valency 2 because it's in group 2. Chlorine is group 7, therefore valency 1. So if we were to draw that, we would have a 2 above there, and we'd have a 1 above there. We then do our crossover, so the 1 would come down to here, and the 2 would come down to there. We don't bother writing 1s, so it's CaCl2. So that's how that works. And we get carbon dioxide, which is a gas, plus water, which is a liquid. So remember that. That's carbonate plus acid gives salt, carbon dioxide and water. So it all goes back to our study of acids and salts. Moving on to the next sheet, we have copper 2 carbonate, if heated, gives off carbon dioxide. What is the name given to this type of reaction? The answer is thermal decomposition. Write a balanced symbol equation with symbols for this reaction. Okay, so it's copper carbonate, which is CuCO3, which is a solid. Remember, it's that green solid. We heat it up, we get our black solid, which is copper oxide, and carbon dioxide gas is given off. Which physical property of carbon dioxide makes it work as a fire extinguisher? I'll give you 1 mark for saying it's denser, and another mark for saying than air. And then dry ice turns directly from solid to gas when warmed. What is the name given to this change of state? The answer is sublimation. And describe the chemical test for carbon dioxide. 1 mark for saying you bubble the carbon dioxide into lime water, and a 2nd mark for saying it turns milky or cloudy.